Well, hello, fellow scientists. I thought I'd make a follow-up video for those of you who would like to look at more practice problems. So here I have 6 typical problems that we can analyze together in order for you to master the different rules that we apply when we analyze significant figures. So, case number 1, we have a subtraction. So if you recall, when we have a subtraction, we're going to look at the number of decimals. So here we have 2 decimals, here we have 3 decimals. This number is the least precise one because it has 2 decimals. It has the least amount of decimals. That means our answer should have 2 decimals. If I keep 2, that means I have to get rid of my 6, right? Because it's above 5, that means I'm going to have to change this for a 4. So my final answer should be 286.54. If we look at the second example, we also have an addition, so we're going to look again at the number of decimals. So here we have 3 decimals, 5 decimals, 2 decimals. This one is the least precise one with 2 decimals. That means our answer should keep 2 decimals. I'm getting rid of actually all these decimals, but the first one that I'm cutting out is a 3. Because it's a 3, I don't need to round, so that means my final answer should be 132.32. If we look at the third example, we have a division. Now in this case, what we need to do is look at the number of significant figures. So in total, we have 4 significant figures here, and we have 5 significant figures here. This one with 4 will be the shortest one, the least precise one, so that means we need to keep 4 sig figs. So 1, 2, 3, 4. That means I'm getting rid of these digits. The first digit that I cut out was a 1. It does not change anything to my final answer. I don't need to round anything, so my final answer should be 114.7. Next case, we have a multiplication. So again, we're looking at the number of significant figures. If you recall, the zeros on the left don't count, so that means here we have 2 significant figures and we have 3 significant figures. So 2 being the smallest amount, we're going to have to apply 2 sig figs over here. That means we get rid of these digits. The first digit that I'm cutting out is a 3. It does not change anything to my final answer, so that means my final answer is 0.87. Now the next case is a little bit different. It is a multiplication, but it has an exponent. So if I have 5.5 to the power of 3, it's really like saying 5.5 times 5.5 times 5.5. So in each case, I have 2 significant figures. If you recall, significant figures, the rules only apply to measurements, not exponents and not constants. So this doesn't count into my analysis. It's not taken into consideration. So 2 sig figs, 2 sig figs, 2 sig figs. I need to keep 2. Now I have a problem. My answer is 166. It's not 16. So what I need to do now is convert this number into scientific notation first before I apply the significant figure rules. So if I convert this, I have to move my period 2 times to the left. So I get 1.66375 times 10 to the 2. When we convert, we keep all the digits at first. We don't drop anything. So this is my conversion. And now I need to analyze how many sig figs am I supposed to keep. We had determined we were keeping 2. So if I keep 2, I'm going to keep these 2. The first digit that I'm cutting out is a 6, right? All of this disappears. But the first one I'm cutting out is a 6. That means this is going to have to turn into a 7. So my answer should be 1.7 times 10 to the 2. All right, so if we look at the last calculation, this one is a more complex problem, so we are going to have to follow the BEDMAS method. So we would be calculating first the inside of the brackets, and then multiplying by this number over here. So if we calculate the inside of the bracket, what are we going to get? We're going to get this. Now, once we multiply this by this, we get the 4.17. If I go back and I analyze the significant figures, I would say, okay, this is a subtraction, so I need to look at the number of decimals. This number here has no decimals. If you notice, we put a little dot here, or I put a little dot, I should say, and this is to indicate that 40 is not an approximation, it's an exact number. It's a whole number, yes, but it's an exact number. So it has two significant figures, but it has no decimal. So in this case, because we're subtracting, we have to look at the number of decimals. This one has none, this one has 1. So my 7.5 could not remain as 7.5. The lowest number of decimals is none. So in that case, I'd have to get rid of the 0.5. So now in this case, at this point, if I'm doing 7 times 0.556, I'm doing 1 sig fig times 3 sig figs. So 1 sig fig being the lowest amount, that means I'd have to get rid of these decimals and only keep 4 as a final answer. So I hope this helps. If you have any questions, you can write them down in the comment section and I will help you out. See you around.